Hello, and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macy, and today I'm interviewing Jeremiah Lowin about the FastMCP framework and how to design and build your own MCP servers. So, Jeremiah, can you start by introducing yourself?
Of course. Thanks so much for having me on. I'm Jeremiah. I'm the founder and CEO of Prefect Technologies, where historically we've built developer tools for data engineers and AI engineers. And more recently, we introduced this FastMCP framework, which is really focused on MCP as a technology and as part of that agentic stack. And I'm really excited to discuss it today.
And do you remember how you first got started working in the overall ecosystem of ML and AI?
Yeah, I was supposed to stay in that ecosystem, actually. Once upon a time, I did my master's in stats. I was hired on Wall Street as a quant and spent the beginning of my career in risk and technology in buy-side finance, building models. And really, back then, this is 2007, 2008, 2009, this is like the wild west of machine learning was like basic recurrent neural nets and stuff like that. And that's where a lot of my research was. And then I took this elongated detour into building tools for people like me and sort of for a long time, sort of just watched as people did all the cool stuff I wished I was still doing. But I love building tools, and it's been a real amazing ride building Prefect to deliver these tools. And so now, as I think AI has suddenly burst into the consumer awareness, it's been extremely exciting to have one foot in the world of what that research entails and requires. And admittedly, I'm a little out of step of like what's happening on the cutting edge, which is extraordinary. And then to have another foot helping deliver it through developers to end users is really, really exciting.
And so that brings us to where we're at right now, which is MCP, which has taken a lot of attention in the overall AI and generative AI ecosystem. And before we get too much into the framework that we're going to be discussing, I'm wondering if you can just start by giving your summary of what the Model Context Protocol is and the purpose that it serves in the overall ecosystem of AI-powered applications.
Of course. So we have this situation where everyone, in quotes, everyone is deploying AI agents, and they expect them to do things. And most of what they expect them to do is interact with the systems we already work with today, whether that's your calendar and your email, or your data pipelines, or your database, or any SaaS product you use or any API you use. And a lot of folks, including myself, have been quite intrepid about writing software to bridge these agents into those systems. But the result of that, kind of because of the popularity and breadth of this ecosystem, is that every single person who wants to use a given API writes, let's say, a Python function for interacting with that API, right? If I want to send a notification through Slack from my agent, I write a Python function. Depending on my framework, I'd probably call it a tool. I attach it to the code that is my agent, and now my agent can talk to Slack. But as agents have become part of consumer products, I don't always have the opportunity to write my custom Python function to give it that functionality. So for example, Cursor is an example of an AI-enabled consumer product. I'm not writing code and handing it into Cursor. I need some way of packaging my tooling so that Cursor can take advantage of it. And so there's this need for a standard way of wrapping business logic in a discoverable API so that an agent can know what it is, know how to use it, and invoke it on your behalf. And so MCP starts life as a protocol for describing that standard. And there's this increasingly cliche description of it as the USB-C for AI, which is to say, no matter what your service is, I used Slack as an example a moment ago, but it could be any database, any service, whatever it is. Your services are on the right-hand side, your myriad variety of agents are on the left-hand side, and MCP becomes a way to ensure that all agents can talk to all services without needing to rewrite that code every single time. And so we could stop there. MCP could just be a standard. It's just a way that we agree that these tools will advertise their capabilities and agents will take advantage of them. But when Anthropic introduced this, they went a step further and they introduced a variety of SDKs to actually implement that protocol and make it accessible to folks. And so now we have this world where MCP isn't just a thing we agree on, it's actually a framework that we can build on top of. And FastMCP sort of has its roots in that outcome.
So digging now into FastMCP specifically, I know that it has gone through a couple of versions, and obviously it's been in a pretty short succession given the time frame that we're talking about. But I'm wondering if you can just give a bit of an overview about what the FastMCP framework is and some of the story behind how it came to be and why you decided to put your effort into it.
Of course. So when the MCP SDKs and the protocol was announced, I think this was last November. So that's November of 2024. I took a look at it that weekend because it's very interesting to me. And, especially being in the data space, the idea of having a protocol for connecting a bunch of stuff is extremely interesting to me. And I took a look at the SDK and sort of saw what it was trying to do and how it worked. And I found that, in my opinion, it didn't stand up to sort of the great idiomatic Python tools that we all know and love for building servers, whatever that means to you. So for me, I had Fast API on my mind when I was looking at it, which is why FastMCP is named what it is, as an homage to that really amazing tool. As an example, if I wanted to have 10 tools in my MCP server using the SDK of November in 2024, I would have to write my own branching routing logic and attach it to the SDK. It was very complicated, and it made me, as a user, as a developer, have to deal with the nuances of how the internals of that framework worked, as opposed to just writing my tool and attaching it. And so I wrote FastMCP back in that November, really just as a way of very, very, very quickly enabling the functionality that the SDK contained, without having to also learn the internals of the SDK. And it looks very familiar to anyone who knows Fast API. It's decorator patterns. So if you want a function to become a tool for an agent, decorate it with mcp.tool, and you're done. The framework takes care of the rest, which is a sort of simplicity goal that I really aspire to in all of my software. And then I think just really resonated here. So we introduced that in November of 2024. I kind of use it casually. MCP is a very quiet thing at the time. I get a call from the MCP team at Anthropic in December of 2024 saying they really liked the implementation and asking if they could vendor it into the official SDK, which I thought was super exciting. And of course, I was like, yes, by all means, and worked with them to make sure that could be done successfully. And so now if you use the Python SDK, you import FastMCP, you import a FastMCP object, which is just so exciting to see this developer tooling get that kind of reach and breadth. And then in the spring of this year, of 2025, when MCP really took off, there was this intense demand for even more high-level interfaces to the protocol than what this low-level SDK provided. And empirically, it became clear that the Anthropic team was focused not only on handling this incredible variety of requests that were coming in at the SDK level, but really focused on making the best possible protocol implementation possible, which left open this opportunity to deliver the higher level, the vendor integrations, the deployment patterns, the hosting, et cetera, at the higher level of this stack. And so we introduced FastMCP v2 last spring to fill that gap. And that's where our efforts have really been for the last few months, which has been just exciting to see it explode.
And the other interesting aspect of the MCP ecosystem, as you mentioned, it's a very new protocol. It's something that is very young, even in terms of software standards. And I'm wondering if you could just give your overall impression of the current landscape of MCP frameworks and tooling, and I guess the pros and cons that exist in that overall space right now.
It's a very scattered ecosystem right now. I think by virtue of FastMCP's inclusion of the official SDK, we've seen a disproportionate share of it through the lens of FastMCP. And so we've seen sort of what people are building. There are many, many tools right now that I would view as ultimately features of a larger ecosystem. You and I saw this in the data space probably 6 or 7 years ago, where you have a variety of open source tooling that isn't quite going to stand on its own, doesn't solve a discrete problem, but definitely solves a friction in sort of the deployment path. I think that's the status of the MCP landscape right now. Part of the friction there is, while there's a standard for how these things talk to each other, there's not really a great standard right now for what a great MCP server looks like. And so a lot of my focus right now, to your point, is how do we evolve these best practices and design healthy servers? Because one of the mistakes people make is they think of, well, this is a mistake I think people make in AI in general. It happens to be really visceral here. They think of these AIs as all powerful, and they don't bother to design an MCP server. Instead, they just regurgitate a REST API through the MCP spec into their agent. And it leads to really bad outcomes because agents are really bad at parsing this huge amount of information and choosing the one route with all the right parameters. And I'm sure we'll have a a chance to explore that in some depth later in this conversation. But really where I see the state of the universe right now is we are live evolving these standards. Many of the conversations I have with other folks in the ecosystem are to learn what they've seen that's effective and to share, in turn, what we've seen that's effective. The one thing that I feel absolutely confident about right now is that the best MCP servers are small. These agents really, as soon as you go past 10 or certainly 100 tools, the agents really start to perform poorly. They get overwhelmed by the choice, and frankly, the token cost is very expensive. And that's a really challenging message to send people at the same time that you're talking about how easy the framework makes it to deploy every tool you can possibly imagine. And that's where, rather than that be an opinion that I have, which is increasingly backed by data, I'd rather if that emerged as much more of just a sort of standard best practice. And that's really where my focus is right now.
To your point of the potential for confusion if there are too many choices, as well as the overall context impact on the proliferation of tools introduced by MCP servers, I'm wondering if you can just talk to some of the ways that people should be thinking about the design of their overall tooling with or without MCP, and some of the stumbling blocks that you see people run into as they start to either build their own MCP servers or start to incorporate MCP into their overall technical architecture.
I found it really helpful to start talking about agent stories in the same way that a good product team would talk about user stories. That's a whole other podcast probably, but just to tease it a little bit. When humans use an API like a REST API, we do discovery once. We look at the whole spec, we find the routes we need, we codify them in our script or in our code or whatever it is, and we never need to go look at the spec again. We just call them as is. And so discovery is a relatively cheap thing that we do. And so you're incentivized to create the broadest, most atomic REST APIs possible to implement them with best practices. Agents are very, very different. They do discovery every single time they show up to the MCP server, which means that a large number of tools is literally expensive and literally an opportunity to confuse it and take up valuable context. They also read everything you put in there, every description, every explanation. So there's a balance to be found between how you explain the utility of your tool and sharing too much. You have a situation where an agent that's an expert in, let's just say, accessing your data warehouse interacts with an MCP server and downloads an immense amount of instructions. All of a sudden, that agent, because of how agents work, is now an expert in your MCP server, not an agent and not an expert in your data warehouse anymore. And so that's where this idea of small servers comes into play. The operative word, I think, is curation. As opposed to optimizing for discovery, you take on this role of curation. You don't want your agent to have to do discovery every time. You want to present the smallest surface area possible so that it can interact with the server and go back to doing whatever its main job is.
And the other interesting aspect of MCP and the patterns that it promotes from the bits that I've been digging into in my own work is that generally in the pre-MCP world of building an agent and providing it with tools, you would be creating these bespoke tools or using whatever functions you have available and running it, exposing it to the agent through probably the same service that you're using to actually execute the agent calls. And so you're dealing with everything very much in process. Whereas when you start to incorporate MCP, it seems that what it is encouraging, at least the default way that you would be interacting, is that the tool calls are then actually executed out of process in a separate service or application, possibly over a network boundary. And I'm wondering how you're seeing that influence the ways that teams are thinking about the overall architectural and scaling patterns of their AI applications as they start to incorporate these MCP services into their stack.
So this happens to be a real growing pain, actually, at the moment. I think you are correct that remote calls, remote MCP servers are not just recommended, but sort of the only real way to do this, because you need authentication and you need all these things to make sure that you're not, to make sure that you as a tool provider have an eye on what's going on and can deploy it and stuff. And also as a consumer of tools, the alternative is to download it and run it locally. And since we're in a world now where instead of writing my own tools, I'm using someone else's, we don't want to be downloading random code and executing it. Nonetheless, when the SDK was introduced back at the end of last year, the only way to run MCPs was to download them locally. And this was hyper effective for distributing the protocol. And also, in my opinion, has created a bit of a nightmare for weaning people off of that way of working and into the remote MCP space. Now you have this intense pressure from vendors now who need to deliver their stuff through remote MCPs, and from the hosted AI clients, the ChatGPTs, the Claudes of the world, who will only work with remote MCPs. And you have the protocol actually struggling, in my opinion, to catch up, not just in terms of what it means to have a remote MCP and do authentication and stuff like that, but also, this is a little bit in the weeds, but something my team is working on right now is these MCP sessions are long-lived and need bilateral communication in certain cases for the most advanced features. Well, that's sort of at odds with having a really nicely horizontally scaled architecture where I don't care, which session my request comes into. And so there's this difficulty right now where the correct way to deploy your MCP server actually forcibly turns off some of the coolest functionality that MCP affords us, because it eliminates the opportunity for that back and forth. And so an active area of exploration right now is the introduction of a new transport that can be horizontally scaled while also supporting bilateral communication. As I said, that's a bit in the weeds, but I think it speaks, your question in general speaks to this sort of growing pain of what's the right way to deploy this. If I am, Joe MCP, and I just have this one tool I want to distribute to folks, maybe I don't care about that. But if I'm one of the largest companies in the world trying to deploy an effective MCP front to my API, this is a real concern, and not an easy thing to change once you put it in the world, because even the change management is still a little bit TBD. So I think you're hitting on like one of the big open questions that obviously I have opinions about and would love to maybe influence empirically, but there's a lot of folks who are trying to solve this issue.
I think that's worth exploring a bit further too. With models, as you said already, whenever you interact with them with a fresh conversation, it's effectively like talking to a newborn who is just very facile with language. And so in that same sense, with these MCP servers and with all of these tools and RAG patterns, the whole purpose is to do that context engineering, is the phrase that I've been seeing thrown around a lot, where you need to curate and provide the appropriate information to achieve the outcome that you care about in that moment. And MCP is one of the ways of managing that context curation through these tool calls, and also through the implementation of these prompt snippets to feed into the context of the model to say, hey, this is what you want to do with this tool, put this into your prompt so that you call the right tool. And with that bidirectional communication, as you said, it challenges the scaling patterns. It brings to mind some of the complexities of managing WebSocket implementations of that bidirectional communication. And I know that server-sent events is one of the ways of managing the push-based communication to these LLMs that has been popular in some of these remote MCP tools. And then it also brings to mind issues around things like sticky sessions, or using some sort of context store for the MCP, whether it's a Redis cache or a database or what have you, to be able to have maybe some transactional elements of being able to allow the MCP server itself to be stateless, but then you're complicating your overall architecture a lot more. And so I'm wondering how you're seeing people start to think about this complexity, and I'm in particular curious about some of the protocol conversations that you're seeing and how people are starting to try and come to terms with the de facto means of building these systems.
I mean, I think you hit the nail on the head there. That is exactly the journey that we have gone on. I think that we actually started with the WebSockets implementation of the protocol. I do not know why that didn't go forward, other than a preference or an opinion. But that's been deprecated. We moved on to SSE for a variety of reasons, including some influence from the large hosting providers. That wasn't deemed sufficient, and so now we've moved into HTTP requests, more vanilla HTTP requests with the ability to fall back onto an SSE stream for the bilateral communication. Where do we go from here? That is a big debate right now. Also, this is a great example of why naming matters. So protocol calls what I just referenced, that end state, calls it streamable HTTP, which has led to a user expectation that responses are streamed, which is actually not the case. And it's little things like that where does that really matter? Is that a thing worth harping on? Well, it is when you have such an emergent protocol. And so you have this deep appreciation, or at least I have this deep appreciation for the fact that there's a committee, an MCP committee that's charged with sort of building this plane very much while it's in the air. This is a plane that's a miracle it took off, but it is in the air and still needs to be built just because of how early it is. In the best possible way, like that is the ultimate win for the protocol. And also it's the greatest risk to the protocol is that the ecosystem forced it into the air perhaps a step early. And so there's a lot of folks working to harden it as quickly as possible. And it means that you are seeing a lot of pragmatic choices that may or may not be lasting choices or may or may not be ultimately congruent with the goals of the protocol. I don't know. My interest right now is in serving the pragmatic needs. Quite honestly, whatever the protocol serves up, we will make do with. We will do our best with it. There are a few places in FastMCP where we have, in the name of pragmatism, gone around the protocol. So when the protocol introduced authentication, it required the MCP server itself to represent itself as a full OAuth server, which is not something we want any MCP users genuinely doing. And I understand that was sort of a waypoint on the way to the ultimate thing, but there was a 3-month span there where the protocol said, if you want to have auth, you need to stand up a full OAuth server. And then did very little to actually make that achievable for folks. And it led to a great deal of confusion. And so in FastMCP, just as an example, we went off protocol, so to speak, and introduced bearer auth, like API keys, basically, as a means of interacting with and securing your server. I think there are going to be more opportunities where empiricism and pragmatism are going to win out over the needs of the protocol. But my hope is that those are detours in the names of usability as the protocol continues to evolve and just represent sort of a hardened best practice. But in particular, the deployment of remote MCPs is something where there's this push and pull effect going on right now. The protocol will put something out. A lot of vendors in the space will attempt their version of it. Inevitably, those will vary in some way. The responses to that will come back into the committee's purview to update the protocol. And we're really seeing this healthy, I think, back and forth. It is the sort of thing that I think in an ideal world would happen before there was intense attention and use of this protocol. But in another interesting way, it's kind of wonderful to see the utility of the protocol shining through even some of these growing pains as the committee works through it.
Another pattern that I'm seeing start to emerge that I find interesting from an architectural perspective is the idea of MCP gateways as a means of aggregating and routing to various tools so that you don't have to tell your LLM application about the half dozen different MCP servers. You just expose it as one and treat that as a single system. And I know that FastMCP has a means of being able to actually handle proxying to other MCP servers, as well as acting as a protocol translation for either standard IO or HTTP-based interaction, as well as going back to your earlier point of just wrap your REST API and turn it into a set of tools. And I'm wondering how you're seeing people work through that discovery and evolution of their adoption of MCP and some of the ways that you're looking to help with short-circuiting some of the dead-end paths in the framework.
It's such a good question. So you're absolutely right. I think the first feature we introduced for FastMCP's 2.0 iteration, which is that more high-level iteration that we're actively maintaining today, was the ability to compose multiple MCP servers into a single server. So sort of a developer-focused gateway, if you will. And the starting point is exactly what you said. I don't want to have to connect 7 different MCP servers to my clients every single time that I set up a new client. If I can compose them into one, then I can only expose one endpoint to my server and let the composition handle the routing and all the related complexity. And obviously, as a framework, we have to solve some problems there around how you do that routing and how you rename things to avoid collisions. But again, that's the role of the framework is to take that on. This is a really persistent request we see at the enterprise level for the very simple reason that MCP has, I think, in some ways slipped the bounds of what would traditionally be lockdown software, which is partially because of the excitement that AI creates and partially because of the ease of distribution. And so you have these CISOs whose hair is sort of on fire because there are God knows how many MCP servers being run inside their organizations to do God knows what. And they it's not that they lack observability on any one of them. It's that there's no way to really govern that use across various MCP servers. So I might be using a server to talk to Gmail, and you might be using a different MCP server to also talk to Gmail in the same company. What if mine's maintained and yours isn't? What if mine has some security risk associated? And so there's this desire to not just sort of publish a whitelist, so to speak, of what servers might be allowed within a company, but there's this desire to actually host them or at least proxy them and just make them available on a protected internal route. This is also a way for companies to solve the authentication problem without users having to deal with it. So I don't really want, if I'm going to have some MCP server that is allowed to say, give an agent access to my data warehouse, yes, I absolutely want to make sure that only my employees can access it. So I have this need for authentication. But do I really want that server and whatever that person who wrote it, do I really want to be at the whim of whatever auth they added to it? Or would I rather harden that with a proper gateway? And so we are seeing a lot of sort of the rediscovery of what would be viewed as obvious in a traditional API world, now in the MCP world. Part of the difficulty and why we're not seeing a simple translation is that MCP reinvents a few things, or at least started off by reinventing a few things that we're now instead adopt established standards, auth being one of them. But even, for example, this is a custom JSON RPC spec for communication. So even a lot of traditional observability tools are unable to sort of peer in naively and need to be tailored for MCP. And so you do see these challenges within these organizations where a gateway, a centralized way of managing all of these things, I think would create a lot of value. But of course, gateways tend to codify whatever the status is when the gateway is built. And with the standard moving so quickly, that can be challenging, which is one of the reasons we did our best to implement it in code in FastMCP.
The other interesting aspect of the ecosystem, and something that you just touched on, is the discovery and evaluation of existing implementations and whether and when to take something off the shelf or to build your own system from whole cloth using something like FastMCP. And I'm curious how you're seeing people work through some of that evaluation and some of the elements of the MCP implementations and the ecosystem that provide some sort of net new avenue of consideration beyond the standard software evaluation practices that we've been honing over the past several decades.
So it's another great question, Tobias. There is the first cut of evaluation, which is standard software evaluation. If I were looking at a server and it were open source, I would like to crack it open and just make sure that it looks like it's sanely written. It's not going to leak my tokens, all the things that we would do for any piece of software to the extent that we can. But then you have this extra dimension of the context engineering aspect, as you mentioned earlier. Does this server properly give my agent the context to make good decisions? And now we enter the world of agent evals, which in my opinion is really, really, really nascent for a lot of reasons. First of all, because agent evals require many, many, many observations, and agents tend to be slow, right? This isn't something where we can snap our fingers and write a test script that makes 1,000 requests to an API. This is something where, yeah, we can write the test script, but come back in a week if you want to see enough interactions with the API to actually make a determination of whether it achieved your goal. Agent evals are also very different than sort of raw LLM evals, in that we need to trace a trajectory of tool choice and outcomes, not just a single LLM interaction. And so all of this is making it very complicated to judge the efficacy of an MCP server. There is not, to my knowledge, there is not like a great or accepted standard for evaluating these tools. An active area of research for us with FastMCP is whether or not we can give users a way to flag whether they believe an outcome was good or not based on some criteria, so that you can capture that and view it in aggregate. This version of the code flagged 10% of the time, and this earlier version of the code flagged 20% of the time. Therefore, we improved it. That type of core experience. But at the end of the day, today, I think it is a gut feeling. I think people spin up MCP servers. They pop them into a chat-based AI interface. They ask a few questions. They see what they get back. And if the answer seems good, off it goes into production. I think that is absolutely not where we'll be a year from today, or certainly 2 years from today. but that is the state of the art at the moment.
And now digging further into FastMCP itself, I'm wondering if you can talk to some of the architecture and design considerations that have gone into it and some of the ways that you're thinking about the design elements to help push people into the pit of success, as it were, let them, default to the best way to do things for whatever approximation of best way there might be, and some of the evolution of the framework as you have dug further into this nascent area.
So the overall design goal for FastMCP, frankly, like all software that we build at Prefect, is simplicity, but also the ability to sort of iteratively adopt it. So the idea is you don't need to learn the entirety of the software before you start learning the software. And so we start with almost this hierarchy of needs of there are three core concepts in MCP: tools, by far that's the most popular, resources, and prompts. And so the hello world of FastMCP is an import statement and a decorator to create a tool, and you're kind of done. There's one or two more lines beyond that, but that's the core of it. And in order to do that, I didn't have to import any types. I didn't have to learn any schemas. I didn't have to read too many docs except a quick start. And I have a fully functioning MCP server that satisfies the base expectations of every AI agent implementation out there. If I want to go further, there's a really cool feature of MCP called sampling, in which your MCP server can actually borrow the client's LLM to do some advanced processing. That is something that your LLM client, your agentic client, has to support, as well as your server has to support, and therefore is not something you should naively drop into your server, because not every client supports it today. In fact, very few do. But if I wanted to take advantage of that feature, then our design goal in FastMCP is to make it possible for you to learn that feature, not every other feature, and add it to your tool. And I think this is, for me personally, as someone who builds horizontal developer tools, what we just talked about is the challenge that I think I enjoy the most in terms of the game of it, if you will, is there's a lot of ways to put functionality in front of people. And there's a lot of ways to just regurgitate protocols that people can, if they imitate them in exactly the right way, yes, something happens. And then a well-designed tool is sort of self-documenting and simple in the best possible way. And that's our design goal with FastMCP. And I think it has really resonated so far. To the extent that it hasn't, there's a couple of things that we've put in the world. Auth comes to mind, being such a moving target, where the feedback from the users has been, I don't know how to use this. I don't get it off the bat. And that's sort of one of the strongest signals we get to go back to the drawing board and really rethink the abstractions we're putting in front of folks. So simplicity and that incremental adoption are the two design goals that we have at the forefront for this framework. Now, when you do that, it means you can do a lot of things. It's a horizontal tool, but it means we're not going to be the right tool for everything, right? So when we talk about simplicity and incremental adoption, that means that we have an opinion that's being expressed in the framework about what's the right path to achieve, complex outcomes. There are some folks, just for an example, there are folks who want to make these completely dynamic MCP servers. So every single time the agent shows up, you get a completely, essentially different set of tools that are highly context dependent stuff. I think this is super cool. I think there's probably a way that we will enable that in FastMCP one day. Today, though, I think that's not a good place for most people to start. And so someone who wants that may not have the best time with FastMCP and maybe needs to go to the low-level SDK.
And so for people who are building with FastMCP, going back to our conversation about best practice, potential pitfalls, some of the design considerations of how to build a well-factored and well-functioning MCP server, what are some of the aspects of the framework that help make that the easiest option, as well as some of the domain knowledge that people who are starting down this path of building an MCP server should be aware of versus just throw it at GPT-5 and tell me to make an MCP server?
So it's a great question. So one of the goals of having a simple framework is to translate the abstraction the developer knows into the abstractions that the protocol requires. So the nice thing about MCP is tools are basically functions. They're Python functions. And so the core entry point, where I can almost guarantee a path to success, is give us a Python function. We'll look at the arguments. Great. We know what arguments you need for your tool. We'll look at the docstring. Great. We know what the instructions are for the tool. We'll look at the return value. We know we know how to turn this object that the developers are really comfortable with, a Python function, into something the protocol requires and agents need. And so we can almost guarantee success for the majority of, Python functions. Where do you get into trouble? Well, let's say your Python function has a pedantic, complex structured pedantic model as one of its arguments. So FastMCP will take that and represent it as the protocol demands, and it will do the right thing, in quotes. Someone opened a bug just yesterday that it turns out that Claude Code doesn't send properly hydrated structured arguments back to MCP servers. Now, Claude Code is such an actively developed project. I'm confident that by the time anyone listens to this bug will have been resolved. But Claude Code, no matter how much you beg it, no matter what instructions you put, will always send structured arguments as a JSON string. And FastMCP, which once upon a time actually automatically translated those JSON strings, but it introduced a whole host of bugs, now we'll do the right thing and reject that call and say, no, this is supposed to be a structured object. Please provide it, as the protocol requires. This is one of those places where you can push too far and you can find the edges of the protocol and you can find the edges of client implementations. I don't know if we have a great way to protect people from going too far in that regard, but our hope is if we can make sure that until they go too far, they have a really good experience, at least the user has a way to discover, oh shoot, I sort of left the boundaries of sanity and I need to come back. The flip side of this, though, is probably the most popular feature in FastMCP is something that I actually had to write a blog post asking people to use less, is automatically converting REST APIs into MCP servers. So this is something that, even though I think it leads to trouble a lot, I think is so incredibly useful and such a core user expectation that it sort of has to be part of the framework. And the idea is you take an OpenAPI spec, you call fastmcp.fromOpenAPI, you pass in the spec, and just like that, you have an MCP server that mirrors the REST API. This is phenomenal for bootstrapping your server. This is almost always a disaster in production because of what we said earlier, that REST APIs are designed for humans for whom discovery is cheap, and MCP servers need to be designed for agents for whom discovery is expensive. And this is one of those places where I'm currently struggling with the right way to guide folks to the fact that they've actually created a bad MCP server by using a seductively easy feature of FastMCP. Just this last week, we were talking with someone who opened an issue who their automatically translated OpenAPI spec resulted in a context of over 1 million tokens. So saying hello to this server overran the context of the LLM client instantly. And you're just done at that point, right? There's nothing to do. And the request was, can we compress the context? And I investigated. We were able to make some significant savings, like 50%, but it was still over 1 million tokens. And at some point, there's not much more we can do other than encourage better design of the MCP server itself than naively regurgitating this. And sort of that's where, again, I said I really enjoy this game, if you will, of design. And this is one of those places where it is actually possible to make something too easy that someone can hurt themselves with it if they're not well equipped to understand the consequences. And that's a real challenge. It's something I take very seriously as a DevTools builder. How do we find that balance? Sometimes we do it better, sometimes we do it worse.
Because of the fact that FastMCP is, at the end of the day, just a Python framework, air quotes around just, it lends the question of, can I just stick it into my existing web application? So can I just add it to my Fast API server or to my Django application? And just some of the ways that you and some of the people who are building with FastMCP are thinking about the degree of integration into their existing application stack and the role that MCP plays in their overall product ecosystem.
Yeah, this is one of the places where FastMCP gets to benefit from really wonderful work that's taking place in the MCP SDK, as a matter of fact. So the SDK provides a lot of utility for converting your MCP server, or I shouldn't say converting, wrapping your MCP server in an ASGI application. It's a Starlet application, but I think that makes it very straightforward to see how to mirror it into especially Fast API as a popular choice. So you could do something similar. Well, I was going to say you could do something similar to get into Flask. I haven't actually looked at that, but you need to get a synchronous application, I think. We'll take that as a to-do following this podcast of how we look into that. But it integrates really nicely into the asynchronous world of Python web applications, at least. And so what FastMCP will focus on here is we have this blueprint. Well, bad choice of words given we're just talking about Flask, but we have this blueprint from the low-level SDK of what it takes to expose the MCP server as a ASGI application. We can reuse a lot of that logic. And now what we need to do is make sure that we guide people to the right way to actually do that. There are some warts. There's little lifecycle things that you have to make sure you invoke in the right way, or the whole MCP server will die. There is work to do to make that a more pure experience, and this is one of the places where documentation really does matter. As much as I said earlier that the goal is self-documenting and it's obvious and incrementally adoptable, I think you and I probably would agree that there's nothing scarier than a project with no documentation. If there's something that it even signals before you even use the documentation about what level of care went into this. So we have done our best to document not just the right way to do these integrations, but the warts that come with them. And this, the easiest answer to your question, I could ramble on for a while. The easiest answer to your question is there's a dedicated page, there's actually 2 dedicated pages in our documents, in our documentation on integrating your MCP server into your ASGI framework. And what we see in terms of practical outcomes, as opposed to developer outcomes, is folks will take their REST API, their Fast API application, whatever it is, and they will expose a new, probably /MCP route that is the exact same server now exposed through the MCP protocol. For simple servers, I think that's really effective. For complex servers, as I said, I already think it's a mistake to do that naive translation. But I think that this combination is effective. You're essentially saying, are you a programmatic client? We have a REST API for you. Are you an agentic client? We have an MCP implementation for you. And I think that's a really effective way to merge the two if you're not sure who your ultimate customer is at this time, or you just want to experiment and see what happens.
The other interesting point that you brought up is that MCP as a protocol requires the server, which is what we've been talking about, but it also requires a client that can understand that protocol. And I know that FastMCP has a client implementation. There are also numerous other clients in the ecosystem. And I'm wondering what sort of content negotiation or capabilities negotiation exists in the protocol, and whether in the protocol or in practice, and some of the ways that you are seeing client implementations stress test the capabilities of the servers that people are building with FastMCP.
There's a little awkwardness there because the servers don't have an amazing way right now of dealing with clients of limited capabilities. Now, again, the protocol, the clients will advertise their capabilities. The protocol is perfectly capable of transmitting what the capabilities are. But I don't want to build tools which are a series of if statements. If the client can support sampling, then we do that. I want to write a tool that does a thing, and I want to sort of take for granted that my client can do it. And so what that is resulting in my opinion, is sort of the least common denominator of tooling, where we are seeing the simplest tools being built because you just don't have a lot of confidence that one of two things: the client supports the advanced MCP feature, or as we referenced earlier, the deployment strategy will support the advanced MCP feature. And so we're seeing a lot of these servers gravitate towards more simple implementations, which is leading to a very valid criticism of MCP, which is, why don't we just use a REST API? If this is really just a formatting thing, what's the point of all this? And that's a whole debate. I think that that's not a bad argument on its face. I think if you actually think about it, you could apply it to pretty much anything. Like, why do we even need REST standards? Why don't we just make raw HTTP requests all the time and just ask developers to do it? Like, I think standards are good. I think agreement is good. I think frameworks are good. However, there are a lot of design decisions in MCP which are additive to these more complex features, which at this moment in time, there's not a lot of incentive for server authors to implement because they don't know about the clients. And because they're not implementing them, there's not a ton of motivation for clients to support them either. The one that I think is probably the one that will drive adoption is called elicitation, which is a very fancy way to say human in the loop prompting. So this is how your MCP server can send back a structured form essentially and say, fill this out or approve this, or get a structured piece of information from either an agent or a human, and then act on that. And I think that is probably so obviously useful that I think it will drive more client adoption of this advanced feature set than, for example, the sampling feature that I referenced earlier. Now, we do have a client in FastMCP. We have a client because we needed a client to test. That's why that client came into view. There's not really a great client implementation. There's great client facilities that ship as part of the SDK. There's not like a great just client object. So we created one. It over time has gotten really versatile thanks to a lot of user contributions. And the most important thing, though, is that the client that we ship in FastMCP is not an LLM client. There is no way to invoke an LLM just by pip installing FastMCP. You need to go and use a LangChain or a Pydantic AI or your framework of choice to bring an LLM along. And our goal with the FastMCP client is to provide a reference implementation for how to interact with an MCP server. My hope is that LLM frameworks and agent frameworks will use the FastMCP client and interact with its hopefully well-designed Pythonic methods to get MCP functionality rather than trying to build their own clients and keep up with the protocol. But we do not aspire to introduce, and I've built agent frameworks. There are wonderful ones out there. That's a hard life. I don't aspire for FastMCP to take the slippery slope and become one. And our client will remain a programmatic client, even as we do add some more agentic facilities elsewhere in the framework.
So obviously FastMCP, it's an open source project. It is something that is definitely very interesting, but as you pointed out at the beginning of the conversation, you have a business to run. And so I'm curious what your overall goals and motivation are for FastMCP and where you envision the project going as you continue to shepherd and contribute to it.
So you're right, we do have a business to run, but interestingly, FastMCP came from a completely unexpected part of that business, and that business is profitable and taking care of itself. And so it's given us a really unique opportunity to invest fully in FastMCP as an open source project and make it the best, most encompassing, every feature we can think of, while also learning what people struggle with. Because, like, candidly, yes, if there is a new business to be built here, I would love to build it. Who wouldn't? And there are ways, been building open source businesses for long enough. I hate antagonistic business practices in open source. And I think that there are ways always to build amazing open source frameworks that are full featured while also building complementary businesses. And so actually, as you and I are recording this, we are in the process of opening up our FastMCP Cloud platform, which is just a really simple way to host these servers for remote access with AI agents. Why are we doing this? Because it's the number one complaint people have. It's the number one thing people are confused by. It's the number one thing that's hard. And it's been interesting, coming from the world of data engineers, where one of Prefect's primary buyers, our ICP, is a member of a platform team, deeply knowledgeable about how to deploy software and best practices and what the requirements are. In the AI engineering world, we're actually seeing a lot of folks who don't have that deep background in deploying software. And that, to be clear, that's an expectation we have, although it was a little bit surprising at first, just because I'm not used to it. And so supplying these folks with a single CLI command, FastMCP Cloud Deploy, basically, or just go through the UI and connect your repo, is the number one request we've heard from folks, which is kind of complicated. Anytime you invoke CPUs remotely, it's a little complicated to ship that in an open source context. So everything we use will go into the open source, right? Because people should be able to deploy these things as easily as possible. But for folks who don't want to take on that burden or don't know how, there's this opportunity to fill those gaps. So we'll be starting with a hosting platform. By the time folks are listening to this, I'm sure you can sign up for it. And there's this hierarchy of needs, though. I'm not particularly interested in a hosting platform as a business, and we're going to keep that as free as we can for as long as we can, because we're not going to pretend that selling CPUs is like a new or interesting business. However, I do strongly believe, based on what I'm seeing, that MCP is how business logic will be distributed to autonomous software. And there is a need, therefore, for folks to not just host and deploy, but version, monetize, advertise, connect, submit for gateways, submit for security reviews. This is entire ecosystem that needs to emerge around the context economy, forget context engineering, which isn't well understood today, isn't well supported today. But the starting point for that is a place where we understand the deployment and observability patterns that really matter for these servers. And so our ultimate goals for the FastMCP ecosystem, for FastMCP as an open source product, is the easiest path to production. Our goals for our commercial products are, once you're in production, if you really want to build your own commercial enterprise on top of MCP, how do we deliver you the tools to do so? And I think that those two products will live very harmoniously. And I don't think any user of either one will feel that they are missing features in the other, because it's a very different set of user objectives.
And as people are productionizing their MCP implementations, as you are thinking about how to make that as simple and straightforward as possible, one of the things that we've touched on a few times but haven't dug into, and I think merits some further conversation, is that question of not just authentication, but authorization, and some of the ways that the user experience manifests for people who are interacting with these AI-powered applications that are then using MCP implementations as part of their means of interacting with external systems, and ways of surfacing that authentication and authorization to the end user in a way that doesn't feel clunky or cumbersome.
Yeah, this is one of the places where I would sort of beg naivete in the most constructive way. I'm not an auth expert, but I'm lucky to work with a lot of them, right? And in particular, our partners over at WorkOS, who I think are really at the forefront of a lot of how this will work. And no surprise, are sort of the first integration that we shipped for auth and FastMCP is one that we built in partnership with them to just try and make this as easy as possible for folks to get, enterprise grade auth without having to learn all about it and sort of have a trusted vendor. This is something that I think is coming into view now for one server. So when I connect, let's make this up. When I connect Claude to my remote MCP server that is secured, my browser pops up. I log in. It's a fairly standard experience. That token is saved, and now we're sort of off to the races, and I don't need to deal with that again. There's this very real challenge of how do I authenticate my service agents, the ones that don't have a browser window and are running in some sort of headless mode or in CI. And I think there's dynamic client registration is the approach that seems to be sort of taking hold now for how those agents are expected to go through the auth handshake. But even if we solve those two headline problems, there's this latent problem of, well, what happens when I compose a whole bunch of servers into a gateway? How does the third nested server properly surface the fact that it needs auth through other servers that will presumably see everything that's going on? This is a problem that I think is poorly solved today. There are a lot of different theories about it. I don't have a strong one, candidly. This is a place where I don't feel comfortable advocating. I don't understand that space as well. I want to trust someone who does, and I would love to see what emerges as sort of best practice around what we might call like federated auth in this case, in this very local case. I don't have a great answer for that. What I am focused on right now, though, is where we do have a good auth handshake and we can get that token, all of a sudden we do have a chance to actually start talking about authorization. Thus far, we've really been talking about authentication. Now, the MCP protocol talks a lot about authentication. It does not make any claims about what you actually do inside your server as far as authorization. And again, my call it naive starting point for this is, well, we know what this looks like in the Python world. We've been building web servers a long time. We know how people like to gate things and say, well, this can only be called by admins and this can only be called by Jeremiah. So I think we're just going to try and emerge those best practices developer experiences in a way that just makes it really easy for people to tap into the claims that they're already receiving from their IDP.
As you have been building and investing your time and energy into the FastMCP framework and diving headfirst into this overall ecosystem, what are some of the most interesting or innovative or unexpected ways that you have seen either FastMCP specifically used or just MCP as a protocol applied?
So I want to call out someone named Bill Easton, who works at Elastic, who is, I think, other than me, probably the most prolific contributor to FastMCP. And we haven't announced this yet, but by the time folks have listened to this, it will be announced, is now joining as a maintainer on the project. And Bill has been pushing the envelope on FastMCP since the day I announced it, basically. And he has a vision, which I absolutely love, that the right way to solve the context engineering problem is not to is absolutely to curate your context and make it small. And he's introduced this entire surface area of what we call tool transformation utilities. So you can take that massive OpenAPI spec and have a YAML document or a JSON document that essentially tells your server how to translate that or curate that into a smaller set of well-understood tools. He's the person who's put that in the world, and it's fantastic. And we want to take that a step further now and introduce what we're calling curator agents. And so the idea is that your MCP server, instead of asking the user's LLM to, here's your menu of tools, learn how to use them and then choose one, actually the MCP server might itself expose an agent, which will allow the LLM, the ultimate LLM, to talk to that agent in natural language, make its queries of it, talk to it. And now that curator agent is the only agent in this story that's responsible for absorbing the potentially massive context that it takes to run and interact with the MCP server. And so this is something that I think is really easy to do poorly and really hard to do well, which is why we're dragging our feet a little bit on it. Bill's probably cringing as he listens to this because that is the case. We're trying to be very careful and not accidentally introduce an agent framework here. But I think this is one of the coolest things I've seen with FastMCP, not just because I think it's super cool, but because it's solving what I think is the looming problem of MCP, is that the easier we make it to build these servers, the more people are inadvertently flooding their agents' context And I don't think a lot of folks who haven't seen this at scale understand how damaging that is. When you have an agent that has a beautifully crafted, parsimonious 600 token system message that, exactly sets its personality and everything's right, and then you hit that thing with a 20,000 token context payload of the one MCP server it's interacting with, and that token payload shows up every single time it interacts with a server, you don't realize how quickly you're lobotomizing your agent. And I think that we can solve that problem by leaning into this super cool, innovative approach that Bill has developed. And so, yeah, I guess this is also a backdoor way of saying how excited I am for him to become a maintainer on the project.
To that point of the massive payload every single time you interact with the server, I'm wondering whether you or anyone you have spoken with have had any considerations of how to make the MCP protocol more of a progressive discovery of here is the endpoint for the MCP server. By default, you have access to a small handful of tools, and then through interacting with those tools, it will give you access to or information about a more detailed set of tools down a particular tree of capabilities.
Yes, I think this is one of the most important things we can do. I actually think, if we can go a step further, I think this is an obligation that FastMCP has as a high-level framework that, for example, the MCP SDK does not have as a low-level framework. The low-level framework needs to expose the capabilities. The high-level framework needs to make sure that they are accessible. Doing that within the confines of the protocol is a little tricky, because one of the first things these agents do, I slightly exaggerate when I say every single time they get every payload. When they first show up, they get every token. And then they rely on that to know what tools are available. And so depending on how the client has been programmed, you run the risk of it not really knowing to discover this. So hypothetically, what you'd want to do is have one tool available called discovered tools or whatever it might be, and have an instruction. You use this to find out what the server can do, and you're sort of hoping that the agent engages in the back and forth that it's going to take. And this is, to give a little away of the roadmap we're putting together, this is a waypoint on the journey to the curator agent, is this entire abstraction. We're sort of referring to it internally as a router. And the idea is I can see every tool, or I can have a new agent in the middle that helps me access tools. And then there's many in-between steps that are programmatic, like the one we're discussing now, which is that I have tools that help me discover tools, or even tools that help me invoke tools. So this is something that I view as an obligation of a high-level framework, as I said, not one that I think we've solved satisfactorily today, because it's one of those places where this space moves so fast, and I do get a little nervous of getting ahead of ourselves and sort of locking in amber an implementation which risks clients being built on it that may not end up being ultimately compatible with how this ecosystem evolves. And so we're doing this carefully. We've tried to set up the right mechanisms in FastMCP, including contrib and experimental categories of tooling. Although when you have something marked as experimental, it doesn't exactly make people excited to go test it out, right, and put it in their clients. So this is all part of the give and take of building a healthy framework. But to your question, like 100%, yes, that is going to be something that is really important to develop here. I think we have an opportunity to do it well, but we're just trying to collect as much information about these large contexts as possible. Unfortunately, today, we usually hear about them because people are upset about them and angry about them, not because people are trying to help us compress them. But that's understandable given the state of the art.
One of the other interesting aspects of the surrounding elements of agentic use cases that I'm curious if you have any thoughts on is the evolution of these large action models where beyond or in particular the maybe the small agents framework that generates code as opposed to just sending structured data, and just some of the ways that the evolution of the model and the agent framework capabilities provide different means of interaction beyond just throw out a bunch of natural language with some structured elements in the middle, how that evolves the utility of MCP, or if MCP is a waypoint onto a more sophisticated means of letting these models actually execute computational primitives.
MCP is one of the ultimate victories for pragmatism over what I'll call merit, but that sounds way too mean, and I don't mean it that way. The MCP protocol is very good, and it solves this problem very well. I think if we were looking ahead a few years, we might design it slightly differently to anticipate some slightly different interaction patterns. we don't have the luxury of looking ahead a few years. And I think the fact that MCP is being adopted so vigorously and so enthusiastically today speaks to the degree to which it solves very real problems. I would look forward to MCP evolving itself into an MCP2 or an MCP plus or whatever, however protocols choose to version themselves, who knows. I would look forward to MCP evolving itself to encounter new interaction modes than for the team that put it forward to have waited or worried that it wasn't perfect. I think that there's a lot of criticism levied at MCP, which is unfair. It didn't perfectly anticipate the agentic world we live in today. I think that's unrealistic and silly. MCP is solving a real problem. So how that evolves and how sort of new computational abilities of agents evolve with it, very interesting for us to speculate about. I don't know. I'll be honest. My world right now is so much the myopia of making sure MCP itself works, which is itself a function of the extraordinary attention. I've never seen anything like it, right? As you and I know, I've been working with my team on Prefect for 7 years. It achieved 20,000 stars last week. FastMCP has been gaining stars for about 3 months and is already at 16,000. So the degree to which developers are flocking to this type of tool is something that I have not seen in my career. As much as I can imagine that and frankly, it's easy to agree with you that new ways of agents working will lead to new ways of exposing utility to them. At this moment, I don't think there's any room for even a second place.
As you continue to invest in this ecosystem, invest in the framework, and participate in this singular moment, what are some of the most interesting what are some of the most interesting or unexpected or challenging lessons that you've learned in the process of building and growing this framework?
I think the weirdest one was having to write the blog post that says, please stop converting your REST servers into MCP servers. And the reason it was so weird is not because of the surface version of weird, where I introduced a feature and then I asked people, don't use it. The weird thing is, I don't think it's possible to have an opinion anymore with all the hype in AI without it being an extreme opinion. And so candidly, I took an extreme opinion in my blog post. I said, don't use this feature. And so now I'm interacting with folks in the ecosystem and they almost apologize. They're like, look, I know you said not to use this, but it's really useful and we're using it. And it's like, there's no opportunity. Maybe podcasts are the only remaining bastion of this, where we can have a more nuanced conversation and say, no, it's an amazing way to bootstrap your server. It's an amazing way to get started. You just can't take the 1,000 endpoints of some AWS API and just snap your fingers and expose 1,000 tools to your MCP. That's going to fail. And so the only way to get that message in the world was to take this extreme stance. And so I think this was the most unexpected action I had to take. A lot of what's happened, to be honest, the most unexpected thing is the extraordinary popularity of this tool. It's a funny thing to say, right? You always hope you write tools or you get to participate in a wave, which MCP is, and I'm just one surfer of that wave, where you hope you get caught up in something like this, and you hope that you ship the software that people love, and you hope for a lot of the stuff. That's unexpected, though. If you go into it thinking all software is going to work out like this, it's a recipe for disaster. So that's, if I'm honest, that's the most unexpected thing. But conditional on that, it's how popular the OpenAPI conversion is, how little people want to understand that it creates bad outcomes, and needing to sort of put this rather extreme, please stop using this feature blog post into the world, which now has its own unexpected knock-on effects.
And so for people who are investigating the creation of their own MCP servers for various use cases, what are the cases where you would say that the FastMCP framework is the wrong choice?
We've tried really hard to make FastMCP the simplest way to get to production for what I'll call like a down the fairway MCP server. If you're trying to expose tools or resources to an agent, that's what it's for. If you yourself are trying to really experiment with what MCP can do, you can be like Bill Easton and do it really well and get invited to actually maintain FastMCP and bring that in. But more likely, you're going to have more success if you go right to a low-level SDK, because we are in FastMCP really codifying an opinion we have about how to build these servers. And that opinion is to build, frankly, simple, curated, and effective servers. That's not to say that all other ways of building them aren't effective. It is to say that we can't guarantee that they're effective as well. So for example, those dynamic servers we discussed earlier, where every single invocation is a totally new server, FastMCP probably not a good choice for you. If you today wanted to do what we talked about a moment ago and have a single tool that helps you discover other tools, FastMCP is probably not the right choice for you. I would like to support that, as we said earlier, but today we don't have a great abstraction for that. And if you implement your own, I don't know, you might run into problems later because we're not sort of presuming that as a core use case. More broadly, though, because we are so focused on the fairway of MCP, I think one of the times I have to tell folks that FastMCP is the wrong choice is when MCP itself is the wrong choice for what they're trying to do, which feels a little bit like a cop-out answer to your question, but we do see it a lot, right? If you're trying to do agent-to-agent communication, I think MCP has a role to play there. I think it's poorly understood today. I think FastMCP doesn't make any attempt to assist you in that. And so while you could squint and say, yeah, MCP seems like the right place to do this, I don't know. I think Google's 808 framework might be the right place to do that, or a custom implementation might be the right place to do that. And so for a lot of folks, they're trying to view MCP as a catch-all for every possible agent interaction. And I think it's really important to bear in mind that MCP is for connecting autonomous software to digital resources that tend to be programmatic. And if that's the type of thing you're trying to do, if that's the USB-C plug you wish you had, then I think MCP is a really good choice. And I think FastMCP is a really good choice for most vanilla applications of that. Autonomous to autonomous, probably not. Programmatic to programmatic, probably not. Really dynamic servers in the middle, probably not. But that I hate calling my software vanilla, but that down the fairway, almost more vanilla flavor, if we just want to connect our agents to our systems, that's where I think we shine.
And as you continue to build and invest in FastMCP, what are some of the things you have planned for the near to medium term of the framework, or some of the other projects or problem areas you're excited to explore in that adjacency?
Yeah, there's a few things. We've touched on a lot of them today. So we really want to solve the context engineering problem. We've talked about introducing agents to assist with that. We've talked about using dynamic tools and dynamic servers to do that. That's a huge area of research for us, and we'll be probably starting with the 2.12 and 2.13 releases of FastMCP, probably at the major focus. A little nearer term, right now, we're really focused on making sure that we have as close to a one-liner integration with every tool folks could want to use. So auth providers, hosting providers, et cetera, just to make sure that it's as easy as possible to get these things into production. And then, of course, I mentioned earlier that we sort of believe that there's not just a context engineering taking place, but there's an entire context economy to be built. And so how do we better integrate all aspects of not just the core of agentic commerce and things like that, but how do we help people build and deploy business logic? If it's not a SaaS application, it's an MCP application. What does that mean? What are the expectations when you ship business logic via MCP? Do you want to charge for it? Do you want to gate access to it? Do you want to have observability into it? Do you want your users to have observability into it? In an enterprise, what does that mean? Versus as an end user, these are the types of research questions we're really focused on right now as this really goes mainstream and becomes a way that people deploy technology.
All right. Well, are there any other aspects of FastMCP or the overall protocol and the ecosystem that it enables that we didn't discuss yet that you'd like to cover before we close out the show?
This has been such a wide-ranging conversation. I think we've touched on pretty much anything. I think my excitement right now, as we're recording this, literally our cloud product is going live, and so my energy right now is really around seeing what people do when that most common stumbling block is removed from them, and they can go, from code to deployed server in less than 5 minutes. I'm super excited to see what that enables. That's where my energy is. But in terms of covering the ecosystem, it is vast. And by the time, 3 months from now, this could be an obsolete conversation. That's how quickly this space is moving. And I would just love to put out an invitation for folks. Our repo is very heavily trafficked. A lot of insanely talented and smart folks there just trying to build the best version of this together, and would like to invite folks to come participate.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing or contribute to the framework, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
The thing that frustrates me the most is something you actually said earlier in this conversation for a different reason. It's sort of that I have to start from scratch every time I call up a new window for one. I use AI all the time, like constantly, right? For all different purposes. But every single time I feel like I'm starting from scratch. And I think that the ways that we have of combating that, whether it's your agents.md or your Claude.md for your written instructions for certain agents, or, ChatGPT has this great memory feature. But what they're really doing is they're recording like facts. And I find that the thing that I spend a lot of my time doing when I'm trying to jumpstart an AI conversation is I'm trying to teach it more stylistic things, right? So if I'm trying to iterate on a draft and edit something, I need to really quickly get my preferences about style into the brain of this thing, into its context engineering, into its context. And I need to do this context engineering, right? And so this is a place where I don't see great solutions in the market. And what I do see tend to be sort of just bigger versions of that glorified key value version of memory. And I'm being silly there. That's not fair, but that's kind of what it is, right? A fact gets retained as memory and it gets recalled later. And so my best case of jumpstarting my conversation is to sort of reference all the facts that I think it should call into memory so that we can get going. And so some way of really remembering the ethereal state of a conversation, the tone of a conversation, how we like to interact, how those are things that I don't see a great solution for. I look forward to having, but yeah, I'm kind of tired with having, basically to copy and paste effectively a system prompt into every different conversation to really get it started on this more experiential understanding of what I'm up to and the continuity of those conversations. It reminds me, I think the funniest thing in the world to me is how frightened I am now of when Claude Code says it's about to compact my conversation. I don't know if this is a fear that you share, Tobias, but it throws away so much information. I know why it's doing it. It's doing it for the same reasons of everything we've talked about on this call, because the context is too big and it has to throw away information to make it happen. But I think that is something that needs to move from art to science as fast as possible, is how do we make portable context effective as possible? Maybe MCP has a role to play in that. I actually don't think I can imagine how people would claim it does. I don't think this is an MCP thing. I think this is an architectural thing. And it's what I'm desperate for as just a constant user of AI tooling.
Absolutely. Especially when you're moving between different services or different models or different tool contexts.
Exactly. And I think, it's like I have this instruction now when I ask an AI to write something. The biggest tell for me, people talk about like delve and M dashes and all this stuff. The tell for me is every single LLM seems right now to produce at some point in anything it writes a phrase to the effect of not just X, but Y. Like not merely whatever, but also a whatever. Like that phrasing, not just X, but Y, shows up in every single instruction I have now, because I hate that phrase so much. To me, that is synonymous with like garbage. And it's one of these things where my worry is I'm editing a document with an AI. It's my voice. It's my words. I'll often do it by transcribing it. And if it edits it and puts that in for any reason, because it thinks it's effective, I'm like, I just polluted my entire thing because I missed, this one little edit. That's the sort of thing. That's a stylistic preference I have. I don't want to have to keep saying it over and over and over. And I don't know how to make that a great memory that's like recalled at a moment. So this is this type of stuff where know my preference. I hate this phrasing. I don't want to see it in any document I look at.
That's how we'll know when we've hit AGI, is you don't have to keep telling it to remove that phraseology.
Don't fall back on these LLM crutches, please. But I do think it's ridiculous. For some reason, I think one of my colleagues, Adam, who also works on FastMCP with me, pointed this out to me, and now I cannot unsee it. So I hope I haven't infected too many people by saying it here. But go through LinkedIn. You'll see it in like 90% of posts. Not just X, but Y.
Absolutely. Well, thank you very much for taking the time today to join me and talk about the work that you've been doing on FastMCP and help us understand the architectural implications of the protocol on how we think about the creation and evolution of AI applications. It's definitely a very important and active problem area, so I appreciate all of the time and energy that you and your team are putting into helping make that a more tractable and delightful experience.
I really appreciate the opportunity to talk about it. It is so exciting to see it happen. And once again, would love to invite anyone out there who wants to build MCP servers to come and join this community we're building around it, because it is super cool to see. So thank you again for the time.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.